Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about stresses and strain. Stress. The force of resistance per unit area offered by a body against deformation is known as stress. The external force acting on the body is called the load or force. The load is applied on the body while the stress is induced in the material of the body. A loaded member remains in equilibrium when the resistance offered by the member against the deformation and the applied load are equal. Mathematically, stress is written as S equals P/A, where S equals stress, also called intensity of stress, P equals external force or load, and A equals cross-sectional area. The SI unit of stress is Newton per square meter, nm2. In CGS units, stress is measured in dyne cm2. Dimensional formula of stress is ml1t2. Units of stress. The unit of stress depends upon the unit of load, or force, and unit of area. In MKS units, the force is expressed in kgf and area in meters square, i.e., m2. Hence unit of stress becomes as kgf m2. If area is expressed in centimeters square, i.e. cm2, the stress is expressed as kgf cm2. In the SI units, the force is expressed in Newton, written as N, and area is expressed as m2. Hence unit of stress becomes as N/m2. The area is also expressed in millimeters square, then unit of force becomes as N/mm2. Also 1 N/m2 equals 1 Pascal equals 1 Pascal. The large quantities are represented by kilo, mega, giga and tera. They stand for kilo equals 103 and represented by k, mega equals 106 and represented by m, giga equals 109 and represented by g, tera equals 1012 and represented by t. Thus meganewton means 106 newtons and is represented by mn. The symbol 1 MPa stands for 1 MEGA Pascal, which is equal to 106 Pascal, or 106 N/m2. 1 Pascal is written as 1 Pa and is equal to 1 N/m2. Types of stress. The stress may be normal stress or a shear stress, tangential stress. Normal stress is the stress which acts in a direction perpendicular to the area. It is represented by S, sigma. Normal stress. It is the restoring force per unit area perpendicular to the surface of the body. It is of two types, tensile and compressive stress. Tangential stress. When the elastic restoring force or deforming force acts parallel to the surface area, the stress is called tangential stress. Tensile stress. The stress induced in a body, when subjected to two equal and opposite poles as shown in Fig. A, as a result of which there is an increase in length, is known as tensile stress. Compressive stress. The stress induced in a body, when subjected to two equal and opposite pushes as shown in Fig. A, as a result of which there is a decrease in length of the body, is known as compressive stress. The compressive stress acts normal to the area and it pushes on the area. Let an axial push Ps acting on a body in cross-sectional area A. Compressive stress is given by S equals resisting force area. A equals axial push area. Equals P/A. Shear stress. The stress induced in a body, when subjected to two equal and opposite forces which are acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, is known as shear stress. The corresponding strain is known as shear strain. The shear stress is the stress which acts tangential to the area. It is represented by T, where V is the resultant shearing force which passes through the centroid of the area A being sheared. Strain, also known as unit deformation. Strain is the ratio of the change in dimension caused by the applied force to the original dimension. When a body is subjected to some external force, there is some change of dimension of the body. The ratio of change of dimension of the body to the original dimension is known as strain. Strain is dimensionless. Strain may be tensile strain, compressive strain, volumetric strain, and shear strain. Tensile strain: if there is some increase in length of a body due to external force, then the ratio of increase of length to the original length of the body is known as tensile strain. It is the ratio of the increase in length to its original length. Tensile strain equals increase in length, LL. 0. Original length, L. 0. Compressive strain. But if there is some decrease in length of the body, then the ratio of decrease of the length of the body to the original length is known as compressive strain. It is ratio of the decrease in length to its original length. Compressive strain equals decrease in length, L. 0. L. Original length, L. 0. Volumetric strain. The ratio of change of volume of the body to the original volume is known as volumetric strain. Volumetric strain of addeformed body is defined as the ratio of the change in volume of the body to the deformation to its original volume. Volumetric strain equals change in volume original volume. Shear strain. The strain produced by shear stress is known as shear strain. We can define shear strain exactly the way we do longitudinal strain, the ratio of deformation to original dimensions. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.